hybrid manufacturing for subject manufacturing process BMCG 2323. Are you ready? Let's get started.
Hi, I'm Niveta Subramanian and my matrix number is B06211026.
Hello, my name is Alexander Pillai, son of Sivanjanam. My metric number is 062110481.
Hi everyone, my name is Christine Jeniraj. I'm from BTMI Section 1. My metric number is B0621104661.
Hello everyone, my name is Nurshazrina Binti Malik and my matrix number is B062110070.
First of all, we're going to see what is hybrid manufacturing is. Hybrid manufacturing refers to a combining additive and subtractive manufacturing process within the same machine. The use of subtractive and additive technology together is not a new concept. For example, post-processing 3D printing parts typically involve NC manufacturing to achieve higher accuracy and smoother surface finish. Application of hybrid manufacturing system is low volume production of metal parts. Machine built for a purpose typical build using CNC milling system to which additive capabilities are added such as 3D printing, noseless, for examples figures. Next, we are going to see key concept of hybrid manufacturing. Integration, innovation, and traditional subtractive methods of production into one automate platform is known as hybrid manufacturing. Additive manufacturing, commonly known as 3D printing, is used for making up an element, parts, or superstructure within an additional component. You may arrange this in any orders. For instance, utilizing laser casting, additive manufacturing may be utilized to construct a metal structure that after cooled could be machined conventionally. Combining the two technology instead provide designers more latitude, mobility, and complexity when designing intricate component or other with extreme geometry that traditional process have proved unable to manufacture. The goal of hybrid manufacturing is to bridge the divide between the computer-aided design (CAD) visualizations, limited potential, and the numerous limits placed on what can be manufactured. Reduce time needed for processing, the requirement for fewer equipments, and simpler monitoring are other advantages.
Let's move on to my part, which is the importance of traditional and non-traditional processes. First one is traditional. Hybrid manufacturing streamlines the processes of design and manufacturing in a single environment, enabling the fabrication of items to be done more rapidly, efficiently, and with fewer machines. A 3D printed part has a lower possibility of error because it has never had to leave the construction environment. And the second one is non-traditional. In comparison to reducing additive machining alone, hybrid manufacturing has a number of benefits. Due to additive capacity to add content to already existing components, it is possible to make up and repair damaged sections only if necessary, which lower the cost of the materials. Because the product is placed only where it is needed and less space need to be finished, it also reduces the amount of reducing machine works. Next, the advantages and disadvantages of traditional processes. Number one is production time. Injection molding in order to create the part of the time, and the advantages and disadvantages is longer production time. The lagged lead time for production operation is a result of the expensive and time-consuming nature of producing the mold. Second is production costs. Typical production and assembly step involves high salting and manpower expenses for the equipment, while the disadvantages is limitation of customization. Customer today are demanding more items that are tailored to their specific demand of the product. And the third one is complexity. Complexity is a significant restrict to the hybrid manufacturing, and the disadvantages is no design flexibility. And now we look at advantages and disadvantages for non-traditional processes. Number one, the advantages is high accuracy. Reliability is currently the primary priority for all companies, large and small. And the disadvantages is high initial cost. It is inappropriate for village and the teeny business for to market the product. The second is less noise, improved alternative to conventional machining and technique. And the disadvantages is high power requirement, which is more energy to cut the tool of surface for the machining. The third one is high production. Innovative technique for machining encourage a high production rates. And the disadvantages is complex machinism. The person in charge must possess the necessary skills to manage the producers related to unconventional machine technique. And that's all from me. Thank you.
me explain about the key features of machines that provide capability of hybrid manufacturing. First of all, it has multi-material compatibility. Metals, ceramics, composite materials, and polymers can all be used with these devices. They can fabricate complicated multi-material components because they have several print heads or tool units that can handle various materials and processes. Next, precision and accuracy. High accuracy as well as precision are offered by hybrid manufacturing equipment in both subtractive and additive processes. They are made to produce high-quality products with complex geometries. Design freedom. In comparison to conventional manufacturing processes, hybrid manufacturing machines offer more design freedom because they combine additive and subtractive techniques. Innovative product designs and enhanced usefulness are made possible by the simple fabrication of internal channels, lightweight constructions, and complex geometries. By doing away with the need for many setups and tool changes, hybrid manufacturing machines save time and money. By placing material only where it is needed and reducing the need for machining, it minimizes material waste. Post-processing capabilities. The application of coatings, surface finishing, and heat treatment are examples of post-processing capabilities that can be incorporated into hybrid production equipment. With the aid of these extra features, it is possible to produce an end result without the need for secondary procedures while also achieving the appropriate material qualities and improving surface quality. Last but not least, scalability and adaptability. To handle diverse item sizes and production volumes, hybrid manufacturing machines come in a variety of shapes and sizes. They are appropriate for both prototype and large-scale production since they can be customized to meet particular manufacturing needs and incorporated into current production lines.
Next is explanation of hybrid manufacturing in producing an electronic product in comparison to its current or common production method. The first step is design and CAD modeling. This step remains the same for both hybrid manufacturing and the current production method. Step 2 is additive manufacturing 3D printing in hybrid manufacturing. The additive manufacturing process comes into play. The electronic product is divided into components. This additive process allows for complex geometries, customization, and rapid prototyping. Next is step 3. Step 3 is traditional machining process. In the hybrid manufacturing approach, use CNC, which is computer numerical control machines. Next is step 4. Assembly and integration once the additive and subtractive manufacturing steps are complete. The assembly process remains similar for both hybrid manufacturing and the current production method. The last step is step 5, testing and quality assurance after assembly, which is testing and quality after assembly. The electronic product undergoes reduce testing and quality assurance, which can be timing consuming and expensive, especially for small production run or prototype. Step 6 is finalizing and packaging for smartphone compared to its common or current production method.
Audio Jungle.